In this lecture, you will see only the solution of a very important problem related to the relative motion of particles from a very famous book by I E Irodov, and the problem number is 1.12. Actually, aim of this problem solution is only to show that we can think the solution of problems related to relative motion by different angles. So here I will try to solve the same problem by different methods, thinking in different manner. Okay. So first of all, see what the problem is. The problem says that 3 points are located at the vertices of an equilateral triangle whose sides equals A. They all start moving simultaneously with velocity v constant in modulus, with the first point heading continually for the second, and the second for the third, and the third for the first. How soon will the points converge? You can understand what in this question has been said by this figure. Let us consider that this ABC is an equilateral triangle whose each side is equal to A. And at the vertices of this triangle ABC, there are 3 particles, you can say, or 3 points. All the particles start moving with a constant speed, which is actually v. But the manner of motion is what? Actually, this particle A always tends to meet particle at B. But B is not stationary. B also tends to meet to the particle number C, while C has a tendency to meet A. So, definitely all the particles will move in this plane and meet at a point which must be equidistant from the initial positions of the particle. As you know, that the initial position of the particles are actually vertices of an equilateral triangle. So definitely the center of this equilateral triangle is actually equidistant from the initial positions of the particle. So definitely you can say that all these 3 particles will meet together at the point O, which is center of this equilateral triangle. Okay, all these particles will converge at this point. Now we have to find actually at what time all these particles meet together. So you can think the time taken by each and every particle is same. If you say that particle A reaches to the point O at time in a time t, then definitely B and C also reach to the same point in time t, because all the particles meet together. So if that time of convergence of particles is to find, we can think only the motion of only one particle. You can think, not the 3 particles. So in first method, let us consider, we take under account the motion of the particle which was initially at B. As you know, this particle starts moving from B and reach to this point O, where the particle meets with the other particles. So in fact, the path of motion will be in general a curved path, but if you think about the displacement of the particle, that will be simply BO. This directed line BO will represent the distance. And if we know the velocity of the particle along this direction BO, then we can find easily what will be the time taken by the particle B to reach to the point O. So let us see, if you will draw a perpendicular from this point O to the side BC, let us say this perpendicular is OD, then obviously this BD is equal to A by 2, DC is also equal to A by 2. and as it is an equilateral triangle, so this angle will be 60 degree, and hence this angle OBD will be 30 degree. Now the problem becomes like this. Let us consider that there is a particle which starts motion at t equal to 0, reach to the point O at time t, okay? And its velocity in this direction of motion BO will be what? As you know that the initial velocity of particle B is along BT, so the velocity of this particle along BO will be simply its projection. So you can say that this velocity is V cos 30, okay? And displacement of this particle is equal to BO. So you can say that time at which all these three particles will converge is simply equal to time taken by any particle to reach to the center of the triangle, and that will be simply distance divided by speed, and this distance will be BO divided by speed, means component of velocity V along BO. So I have written here VBO, which means component of velocity V, which is directed along BD in the direction BO. And as you can see that this BO will be what? This BO will be A by 2 by cos 30, and VBO, this is V cos 30, okay, you can see. And so this will be A divided by 2B, and this will be cos square 30 degree, and cos square 30 degree is 3 by 4. So this result is simplified as t equal to 2A by 3B. So this is the time when all these three particles will meet together. But I have taken only one particle under account, and describing its motion we can find this very time. Okay. Now we will see the second method to solve the same problem. Here we consider the two particles under account. Let us say we consider the particle B and particle C under account. Initially, the velocity of B is V, which is directed along C, and the initial velocity of C is also V, and it is directed along CA, you know, okay. So you can take the projection of this velocity V of particle C along this line CB, and that projection will be what? That projection will be V cos 60. So now you can think that there are two particles. Problem is changed here. First particle B is moving towards C with velocity V, and particle C is moving towards B with velocity V cos 60. Now take this particle C as the reference and discuss the motion of particle B. Okay, when you will take C as a reference, then C will be at rest in its own frame, and velocity of this B with respect to C, that is V relative, will be what? This is V plus V cos 60, because motion of B and C with velocity V and V cos 60 are on the same line in opposite direction. So the magnitude of relative velocity will be sum of these two velocity, and this will be V plus V cos 60. This is V plus V by 2, which is 3V by 2. Okay. Now, as you have considered that C is a reference frame, so C will be at rest, and this B will then meet to C at this position C. Although actual state of affairs is different, the particle is actually meeting at O, but this is just a technique to solve the problem. We can think that C is stationary and B meets to the particle C at its initial position C. And so the distance covered by this particle B to meet with C before its meeting, that is S relative, this will be A. And therefore, the required time of meeting will be what? This will be S relative divided by V relative. And you know that S relative is A and V relative is 3V by 2. And so this is 2A divided by 3B. You can check, the answer is same. Now, the same problem may be thought in this way, in third manner. You can think that this particle C, which is moving with velocity v directed towards A, this particle can be thought that this is moving in the direction of BC with velocity v cos 120. We simply take the component of this v of velocity particle C along BC, and that will be v cos 120. So you can think that particle C is moving away from this B with velocity v cos 120. So again, when you will take this C as a reference frame, then it will be stationary in that frame, and the velocity of v with respect to C along BC, that will be v minus v cos 120. But 1 cos 120 is minus 1 by 2. So this will be v plus v by 2, and this is 3v by 2. And again, as C is stationary in its own frame, so you can say that in this frame B will meet to C at this position C. And so the distance described by E, which is called relative distance covered by B with respect to C, this will be S relative equal to A. And therefore the required time of meeting will be what? This will be S relative by V relative, and this will be A divided by 3V by 2, which is equal to 2A by 3B. So I think you have understand how we can thought the different mode of thinking to solve the same problem. Okay, thank you very much.